Okay, so for this first short talk, we're going to have Alex and Alex from Checkpoint. So which one is Alex? Well, actually, you have the pictures on the screen. So Alexander
Chalitko. Yeah.
And Alexander Trefimchuk
Yeah, right.
from
Hard to pronounce.
Hard to pronounce, but
sorry about that.
They seem very nice, actually. So you have the floor. Thank you.
Thanks. Hello. So first of all, I'm very pleased to present to such a great crowd here at BotConf. And let me introduce ourselves. My name is Alexander Chalitko, and I'm a team leader for malware reverse engineering team at Checkpoint. And this is my colleague, Alexander Trefimchuk, who works as a malware researcher in my team. So today I will be talking about DGA clustering and analysis, mastering modern and evolving threats, and in context of the system that we've developed over the last couple of months called DGA Lab. And then my colleague will present a live demo to you. So let's move on to the presentation. DGA, I bet you've heard it a million of times already, and nevertheless, let's discuss briefly what DGA is. DGA stands for Domain Generation Algorithm, and this algorithm periodically generates a large number of domain names, which are known to the malware author. The malware author then pre-generates a tiny number of those domains before the start of the campaign. Malware on client machines starts its attempts to connect to the CNC server from checking for internet connection, and if it's successful, it then iterates over the malicious domains until it finds one that resolves to an actual IP address and is accessible at the moment. And this kind of attack, as it was already said, is hard to preemptively block. So let's define the problems while fighting DGA malware. We don't know which domains will be pre-registered by attacker, and there are too many domains that will be registered every day. So, and only a small number of them will actually be contacted by the malware. Therefore, it's not feasible to pre-register and block them all, making syncholon not effective in its current form. And this entire process can be easily automated because syncholon involves some kind of cooperation from law enforcement agencies, such as Europol, for example. So that's why we've developed our system called DGA Lab. Overall, this system greatly helps us to categorize and preemptively block DGA-enabled malware very efficiently. So that's why we want to share this idea with you. Let's talk about it in more details. We support 4 different types of DGA. The first one is the simplest type called static DGA. Static DGA is type of DGA when the generated output is not dependent on date or seed, and it's most likely the kind of DGA that will generate the same domains every time. So it's simple to re-implement the algorithm and grab the output and block the traffic according to that. The second type of DGA is date-based DGA. So the current date is used as input for the algorithm to generate domains, and it's usually a very big, and we can reverse engineer this executable once, re-implement the algorithm, and pre-generate all future domains. The third type is seed-based DGA. This type of DGA utilizes hard-coded seed as input for the algorithm. That seed is usually a very big number, and which can be predicted or easily extracted from the executable without reverse engineering. In addition, adversaries can change the seed between the different executables while they're using the polymorphic cryptors, and also between the different campaigns. So simply re-implementing this algorithm will not help you to get all the domains from different executables. And the most annoying DGA is a combination of date-based DGA and seed-based DGA. So we need a special type of virtual machines to deal with it. Let's take a look at the main features of DGA Lab. We have designed DGA Lab to be able to operate successfully with all types of DGA. To do so, we created a separate module for each family type. The system itself can be easily extended to support even new threat types when they arise. While many others generate only a partial list of domains, we generate a full list almost every time. This means an extremely high and early detection rate. DGA Lab has an ability to combine multiple similar DGAs into one category. And also, as we're trying to generate a full list of domains, we pass the traffic through our fake-DNS server. And afterwards, the malicious traffic never leaves our environment. So the malware guys have no clue that we're investigating them. And however, we can whitelist any domain to be accessed by the malware and return a real page to it. This is necessary as a lot of malware is checking for internet connection and will just stop the emulation if they detect no connection, and so generate as 0 domains after all. And also, we don't need a lot of resources to process large amounts of samples daily. The average emulation time is approximately like 3 minutes. And restoring the virtual machine to initial state is almost instantaneous due to the use of the RAM drives. We also collect and provide a lot of statistics such as families, categories inside them, detection rate, samples prevalence, and the most active periods, and a lot more. And this information is highly useful for intelligence needs and is represented in a friendly manner on our web interface. Once we've got generated domains for a category, all further domains that generated the same domains, even those undetected by AV engines, for example, zero-day malware, will be assigned to that category as well and detected based on these domains. And most vendors can look only into the past, while we can pre-generate domains for the future. So this is achieved using a specifically designed custom virtual machines. This feature gives us an advantage of generating domains and possibility to block threats for patient zero computers. So what's under the hood? We implemented new features and refactored a lot of Cuckoo Sandbox and CookieMon code to deal with the main problem of emulation, detection of virtualized environments. So we also increased stability by fixing a lot of critical bugs. Also, from the beginning, we noted that VirtualBox, which is used in conjunction with Cuckoo, does not meet our requirements. So after a lot of testing, we've decided to use a VMware Workstation instead. DGA Lab doesn't use any product out of the box, so we implemented a lot of fixes and adjustments and refactored a lot of codes to achieve our goals. So this includes fixes to Cuckoo, CookieMon, DLL, NetBIOS, and TCP/IP stack on Windows that we use inside our virtual machines. Also writing our own kernel mode driver. And also we developed this kernel mode driver to handle problems with detection of virtualized environments and other fixes. This helps us to increase our successful emulation rate by 40%. So let's define our categorization system of the malware. We download samples that's with a pre-assigned family that we've got from our samples feed provider, and then we emulate those samples using a number of VMs. We take the results and categorize them using a unique name for each category. So we can also reassign samples family after the emulation stage. Let's imagine the situation when we received a sample that feed provider marked as SIMI family. So after the emulation, we recognize that the generated domains actually belong to TINBA family. The DGA Lab reassigns the samples from SIMI family to the TINBA family automatically, based on the domains. So let's take a look at the DGA Lab overall statistics. At the moment, we support more than 28 distinctive families. Also, DGA Lab has already processed more than 100,000 samples. 500 plus categories have been discovered, and we collected more than 700,000 unique malicious domains divided by categories during the DGA Lab operation. So let's take a look at a specific family. For example, well-known TINBA. We've got more than 68,000 total samples processed just for TINBA. 120 unique categories were detected, and more than 100,000 unique domains collected just for this family. Here are the statistics by category for TINBA. We can see that the most prevalent categories here, and this is really useful for intelligent guys, so they can see which category is prevalent in the moment. And let's sum up. We gather domains even from samples that fail to execute on other popular platforms, such as Aristotle, malware, due to our fixes. DGA Lab is able to automatically feed gathered data to threat intelligence databases. We achieved an almost zero false positive rate. DGA Lab features lightning-fast categorization even of an unknown malware using the generated domains. And we're pretty efficient. So emulation of one sample takes approximately 3 minutes. And now I will pass you over to Alexander Trifonchuk for a live demo of our system web interface. So thank you. We'll switch laptops. So please.
Now I will demonstrate our DGA Lab system web interface. Each family has its own DGA source implemented in Python. Families are grouped by the first letter in alphabetical order. The static families are displayed in black, and the emulated type families are displayed in blue. The emulated type families has its own tooltip with basic identifying information. The family type, number of categories, total number of samples, percentage of family samples in DGA Lab, total number of domains of this family, and family creation date. Let's look at static date-based family, for example, config.rc. We have the following information displayed on this page: the family name, family type, number of domains per day, TLDs list, possible domain lengths by the algorithm, and brief family description. The DNS list for 5 days is displayed at the bottom of the page. Each DNS list can be cropped out to 2000 domains to optimize a preview of this page. But the whole DNS list can be exported using export data button. So let's look at the static non-date-based family, for example, she's. We have similar information displayed on this page, but there is only one DNS list. Sorry. So let's take a look at emulation time family, for example, TINBA. The family statistics are displayed at left top corner of the page and contain the following information: total number of samples processed, skipped, with category and without category, and percentage of samples with category. A simple graph to the right of the statistics box displays the number of samples with category in blue and number of total samples in gray per day for the last 60 days. We can see how many samples were analyzed and how many of them have been assigned to a category. The list of categories displayed at the bottom of the page and displays the number of categories in the header. Each category has the following information: the category name, first domain, TLD list, number of domains, number of samples, and date last seen. The last seen on field shows us last time we saw a sampling for this category. We use this data, we can recognize active categories. Let's take a look at some category details. The category details are displayed at the top of the page and contain category name, family name, first domain, TLD list, category creation time, and time last sample was added to the category. The references list is displayed below the category details, and there are SHAs 256 of samples which belong to this category. The domains list is located at the bottom of the page. Each domains are displayed in the original order of appearance. Let's take a look at some analysis reports. The file details and the analysis details are displayed at the top of the page. The DNS list is displayed at the bottom of the page. Let's take a look at TINBA category statistics. The first diagram displays the top 25 categories by the number of samples in each category. We can easily see which category is most prevalent. We can assume that each category can belong to a different threat actor. The family category statistics are displayed below the diagram. There is corresponding activity graph for each category. Each graph is composed using first seen sample dates obtained from VirusTotal and grouped by the months for one full year. This data shows us categories activity and helps us see a campaign's activity time range. It's time for scheduling statistics. The categories activity for the last 30 days is displayed at the top of the page. We can display the following types of events: creation of a new category and addition of a samples to a category. We can update the threat intelligence knowledge base with a new category almost immediately after it appears. The scheduling activity for the last 30 days is displayed at the bottom of the page. Each line has the following information: date and time when search and download task was started and finished, the family name and the number of downloaded samples. Finally, let's look at the export page. Export page allows us to export all the DGA Labs data in JSON format. We can export all types of families or emulated type families only. For the database DGAs, we have option to export domains for ± 45 days, including today, or to export domains only for today. Also, we have option to select pretty print if we want an easily readable JSON as the output. Thank you.
Okay. We have some time for questions. John, you're smiling. You have a question. No?
This guy here.
Là-bas.
Hi, Martijn from Forest Bulletin. Thanks, guys. That was interesting. So one question. There are also, I believe, DGAs that use some kind of unpredictable value of the future. Say, the euro-dollar exchange rate at midnight.
I can hardly hear you, actually.
Okay, so I believe there are DGAs that use that cannot be predicted because they use an unknown value of the future.
Yeah.
Say some kind of
Seed. We call it seed.
Well, no, but a seed. For example, a DGA that uses, say, that looks up some data on the internet that can't be predicted.
Okay, on the whitelisted like server, like for example Twitter or something like that. Yeah, so it gets the seed from there, and
yes.
Yeah. Okay.
Have you looked at that, or
we sure can take care of that kind of situation because we have like whitelist of domains from Alex first 1 million, and we can access the malware can access whitelisted hosts, so it can get the data that it needs to produce domains. So even if it's on the third-party servers.
Okay, thanks.
There. State your name.
Dmitry from Secure. Whoa. Check. Thank you, guys. Спасибо. And the question is, how do you integrate DGA lab results or DGA lab into checkpoint products?
Actually, we're working on that integration right now, and we have a product that is using some kind of real intelligence database on our gateways, and it inspects the traffic on the network level, and so we feed our database to that solution, and it inspects the traffic, and if it sees any of those domains, it just logs this communication and raises an alert or any other action that is selected by administrator.
Okay, I see. Is it checkpoint firewall?
No, it's not a product.
Yeah.
It's
Okay. Okay, thanks.
There was another question around here. Yeah.
Hi, Jonathan from Fox IT. So you guys basically take samples and you classify them based on domain characteristics? So like the domains look similar and that's how you make groups, right?
basically inside the different families. For example, you'll take the one family, for example, Timba, and you have a different seeds of each sample that is hard-coded in each sample, and this will generate a different domains for different type of samples. So we take the output of the sample and we categorize this by domains that were generated. Basically, we have, for example, 1,100 samples and only 120 categories inside them, distinctive categories, because out of this large number of samples, we have only 120 distinctive categories that generate the same domains. So each of the category generates the same list of the domains. So it's limited number of categories.
Okay, yeah, because I was wondering if you also do some classifications beforehand. So if you know samples are related already, you can already classify them in certain groups without checking DGA patterns, basically.
We're doing like also SHA 256 skipping procedure. So we don't process the same samples twice, but we don't categorize them based on some other things other than domains, actually. So we pre-generate domains, look at these domains, and if they are the same, we're putting it in the same category.
All right.
That's it.
Thanks.
Last question here.
I don't think it's on. There we go. First of all, you said that you have the ability to export the stuff that you detect to other threat intelligence systems.
Yes, right.
Is that something that is accessible to anyone, or do we have to do that by request?
Actually, at Checkpoint, we have like a lot of open source products lately, like Droid, like the plugin that were developed by our system called Labeless for IDA for reverse engineers. So we share a lot of data, but this project is actually like for internal use only, because it's like a competitive advantage for us. So we're sharing the idea of it, but we're not sharing the databases actually.
Oh, so you don't have any kind of feed or anything that you can share with other people?
We're just don't have it at the moment. Maybe later, but at the moment we don't have any.
Okay, and if I have another minute, I just wanted to get a clarification on, so if you get a malware sample, can you immediately derive what kind of algorithm is used to generate these domains? Don't you have to like run a sample multiple times, different dates and different times, just to determine if it's time-based seed or a different kind of...
Okay, for example, it's a kind of long answer, because if it's just a date-based malware, we have like we're implementing the algorithm using the reverse engineering first of all.
Okay.
So we're implementing this algorithm in our system, so we don't need to run the sample every time. We're just testing if it's date-based malware first of all. So we're running the malware first of all with a one date, then with another date. If the outputs are different, then it's probably the date-based malware, and we are further investigating that and reverse engineering it. And
So you do not just dynamic analysis as well, you also do more of a static
yeah,
analysis.
for the
and-
cases that we need, but it's only need to be done only once, and this is the advantage basically. And this is all the information within one system. And the more harder case is when you have like a date-based and also a seed-based. Seed is like a random number, for example, and then we need a special type of virtual machine, as I mentioned. So it will adjust the date, and we pre-generate domains for the future, for example, for the future for 45 days, and then we feed it to the threat intelligence database.
And you do that using Kukumon by modified DLL, and you just
It's no, basically not. As I said, it's like we refactored a lot of code. It's it's like not a cuckoo anymore, but it's done using the different technique and the fake DNS servers and everything else. So we're using another approach with that. But we can do even with this kind of DGA type, we can do good stuff. So I think.
okay. Well, thanks.
Thank you. Okay, thank you very much.
Thanks.
Thank you. Thank you.